Arrange the means, isn't it?
Yes.
Arrange the means in order, ascending order, right? Ascending order. I hope Rampedi is listening, because Rampedi, I'm doing this because of you. Number
Yeah,
two,
yeah. Thank you, sir.
number two,
Standard error and the standard error.
standard error, because the problem is balanced. We agree that the standard error,
Find the standard error of each average.
thank you, is given by the square root of MSE over R, right? Rampedi, are we fine so far?
I'm following, sir.
The third one, you find the ranges, right? Ranges from Duncan's table. Duncan's table. That's what we agreed on last week. We're writing that quiz on Friday, don't forget. Number 4. So the scope is whatever we're going to do even this week is part of the Friday's quiz. So now you find what? Significant ranges. Significant ranges. How do you find this one? Is step 3. Is step 2. Step 2 multiply by step 3, right? Do you understand the shortcut? Step number 4, to find the significant ranges, you multiply your standard error with the values from the Duncan's table. Step number 5, compare, isn't it? Compare. The comparison part is the one which it was tricky, but those who attended on Friday, they managed to get clarity. They compare the means now. Those who attended the what do you call it, consultation session on Friday, they were able to get what is happening. So now, Rampedi, are you still there?
Yes, sir, I'm following. I think this is what I was doing.
Thank you.
Yeah.
So now, can you allow me to put the stroke here? Student Newman-Kells method. You still arrange the means, you find the standard error, you find the ranges from student Newman-Kells table. I'll project the method. We'll do an example. The only difference now is when you want to find the ranges now, you find it from standardized Newman-Kells table. Is there? I gave you the tables. And then step number 4 will remain the same. Step number 5 will remain the same. We're talking about a problem when in a case where we're having a what? A balanced CRD, right? Don't confuse this with blocking. The B in this case, I'm referring to a balanced CRD. So allow me, any question based on this method, the Duncan method? Any question? Can I get a question? Or Rampedi, are we fine here? Do you understand these steps when using
Sure.
Duncan?
Yes, I understood.
Yes.
Those.
Seems like there's a question. Who's talking? Except Rampedi. Feel free, guys. Feel free. You are writing Friday. I don't want you guys to say, hey, Marulege, it was rushing. Yes, Makuelele. Makuelele.
On the
Makuelele, are you talking? Can you please continue because I cannot hear what Makuelele is saying? Now I want to, okay, it's fine. Yes, Makwelele. Oh, sorry. Memory.
Sir, since you're showing
Yes.
us the examples for balanced problems, are you yet to show us the ones for unbalanced?
Yes. The only difference is step number 2. When it's not balanced, the only thing that is going to
Okay,
change is step number 2. So I'll show you how to find the standard error for a problem which is not balanced. Agree. I showed
right.
you
Thank you, sir.
for for LSD, right? For the LSD, you still remember, isn't it?
Yes,
Okay.
yes.
Thank you very much. Makubele, what do you mean by why I'm seeing a car? What is happening?
No, sir. I was saying that car is disturbing me.
Oh, thank you very much. I hope you had the complaint leadership. Please, Sacramento is failing to focus because of the car. I assume that is the car on the background. So please, let's make sure that Makubele is also enjoy the session. So please, the background is disturbing. So now, can you please allow me to move to Newman curls, and from there I will do the Duncan multiple range test when the problem is not balanced. I'll show you the difference where we will get the difference. So allow me to stop this. Let me share so you have this note, guys. Please, if you have time, go through the notes before class. It will help you to understand better. Because today is a must. We must conclude. It's a must, guys. We must conclude this chapter 2, part 1. Tomorrow I must go to chapter 2, part 2. Even chapter 2, part 3, I think we can even cover it tomorrow. So, student human cares, I was accused that I was fast last week. I think it's Wednesday. Someone said he's tired. I had to stop. So the third method is Newman cares, which was introduced by Newman in 1939, and Kels decided to adjust the formula. Now it's called the Newman-Kels test. As indicated here, Newman-Kels method is similar to Duncan multiple range test method. That is that's similar, except that when you want to check the value from the table, you will use the what? You use the standard studentized Newman-Kels. So here's when you want to find the ranges. Remember, I said step one, you arrange the means like the way you did with from Duncan. Step number 2, you will find what? The ranges. But now the formula that we're going to use Q alpha. I think when you're dealing with Duncan, you're using R alpha. Now is Q alpha, and even the ranges now, instead of RP, you are using K. That is the only difference. Just the notation, the table that you'll be using. So let's check. You arrange the mean from low to high. It's the same thing as saying you arrange the means from in an ascending order, from lowest to the largest. Obtain the standard error. You know how to define the standard error, guys. Find the tabulated values from studentized table. What did I say about Duncan? If we're having 7 treatments, how many values will we collect from Duncan table? Suppose we're applying Duncan method. Suppose we're having 7 means
6.
7 treatments, sorry. How many values will you collect? We'll collect
6.
6, right? So the procedure also apply to what? Thank you. The procedure will also apply to studentized table. When you go to that table, if you are using 5 means, you will collect 4 values from that table. And then now, to find the ranges, step number 4, you multiply the what? The values from studentized table with what? With the standard error. That's why I said step number 3. Step number 2 multiplied by step number 3. The values from the table, you multiply with what? With the standard error. From there, do the comparison the same way like Duncan multiple range test. Do the what? The comparison like Duncan multiple range test. Any question? Any
Sir,
question, guys? Oh, let me.
is
Yes.
this for
Sir,
balanced or unbalanced?
it's for balance. Still for balance. I want to move back to unbalanced.
All right.
Yes, it's for balanced. I heard 2 voices. The first one I think was Tuto or Tato. Who was
Oh,
talking?
yes, it was me, say. I wanted to ask about that formula,
Yes, can you please
yeah,
indicate
standard error.
raise up your hand there, raise up your hand there so that I can see who's talking. Just click that thingy. Yes. Oh, Sibola. Yes, Sibola.
Yes, sir.
Yes.
I wanted to ask Ori for both unbalanced and balanced. We're using that same standard error and that formula of MSE over R, the root of MSE over R.
So far, can someone help me to answer this question? I think Christopher, we are the right person to answer this question. Why did I say Christopher?
You said this one is for balanced.
Oh,
This
okay,
one is for
thank you.
balance. So now, before I can go to taking multiple range test, can you allow me to show you a case where the problem is not balanced? What you have to do, the only part that will be affected is the denominator. The denominator, which is what? The R. The R will be affected if you're using Newman curves or Duncan. You have to first calculate what is called the harmonic mean. Or let me. When the problem is not balanced, here it is. The standard error for when the problem is not balanced. Oh, let me copy this. Oh. Copy. So let me go here for the standard error. Step 2. When the problem is not balanced. It is, my brother. If the problem is not balanced, you use this formula for step number 2. Step number 2 now it will be affected. I'm not sure if you can see what, yeah, okay. Let me know if you can see the whole thing. Can you see everything, guys?
Yes.
Yes.
So these are the denominator here will change to RH. Can you see it now? RH is the harmonic mean. So if the problem is not balanced, you must first find the harmonic mean. The harmonic mean is given by this formula here. This is the harmonic mean. Like we have a question, we have a problem which is not balanced, right? We have a problem which is not balanced from our notes. Do we have it? I'm not sure if we have it here or it's from the tutorial. It's the tutorial question, right? I think we have one question which is not balanced. Okay, so what should I do? Should I go to the tutorials? Or
So
that
can I
problem
copy?
from?
So can
Yes.
I copy
Okay,
that?
sorry.
So can I copy
I'll
that
go to the
formula of
tutorial.
harmonic mean?
Okay, it is. Sorry. I don't know, it's not this one. It's there, but it's there from my notes, my brother. Do you have the notes? This note, are you able to access my files?
Yes, I'm able to access your files.
The formula is there from your notes.
Thank you, sir. You can pass.
But since we want to, since we want to use it, it's fine because we want to use it. I want us to go to a case where we have unbalanced problem. I want you to give me this part, the RH. I want to check if you know how to find the RH. But remember, the formula for the standard error, you still have the MSE, right? MSE now is the square root of MSE divided by RH, where RH is given by this formula. Yes? Manyam.
Morning, afternoon, sir.
Afternoon, my brother.
Yeah, there's actually, I may say, sorry for joining late. I was having network problems here on the computer. But now, I want to ask here this question relative to the bias. On the biased, the
Balanced
standard,
or biased? Balanced?
the balanced, the balanced,
Yes.
like simply saying the sample size are equal. The errors of the standard error of the treatments is the same, ne? Or is different?
The what?
Standard error S Y subscript Y I period.
You are referring to what, Mr. Manyam?
The error, the S error, the error which you are going to use, the like when we take the square root of the MSE over the replication.
Yeah, oh, that is correct. That one is the same because the problem is balanced. You have to find only one standard error. The good thing
Okay.
about Duncan and Newman curls, even if the problem is not balanced, the standard error you are going to get one. Not like what we do with LSD, that when the problem is not balanced, we have to find more than one LSD values. When coming to Newman curls, we're going to find only one standard error. So even if the problem is not balanced, at the end of the day, we'll have one standard error. I'm not sure if I
Thank
answered
you,
your
sir.
question. We're
I,
going to that one. They said I must project the question where the problem is not balanced. So I'm going to close this for now and open the tutorials. I'm asked to open it. I'm not sure if this tutorial is what we have that side. Tutorial 1. I'm not sure if this is what we have. Is this the tutorial, guys, that we're talking about? The one which is not balanced?
yes, sir. This one is not balanced, sir.
Yes. So, please, can you please, what is important now is tell me how many treatments do we have from the problem? How many treatments do we have? We have 5, right?
I have
1,
5
2,
treatments.
3, 5. So please write the 5 down and again indicate that how many replications do we have from the first treatment? How many?
The first
Write them down. Write them down, please. Write them somewhere. You see we have 2. How many replications do we have from the second and up to the last one? Please write this information down. From there, I will show you how to find the harmonic mean. And the other steps are the same. So the first treatment, help those who cannot see what we're talking about, Mr. Banyama. The first treatment is having how many replications?
The first treatment is having 2 replications. Is it?
The second one?
The second one is having 6.
6. The third one
is 12.
Please confirm the values that we are getting from Mr. Manyama. The fourth one?
4.
And the last one is 2, right?
Is 2.
Yes. So far, I just want to show you how to find the harmonic mean. The MSE still you are going to find it from the ANOVA table, right? So how to find the harmonic mean based on this problem? Allow me now to share the whiteboard. I'll ask that information again, Mr. Manyama. The one of you said T1 is having R of what? R equal to 2, right? And treatment 2, you said R is equal to what? Let's go, Manyama. Are you still there? Can someone help us?
It's 6. 6. The second one. The third one is 12.
6. I'm told this one is 12. The fourth
And the
one?
fourth one is 4.
4.
With the other one is 2.
This one is 4. And the last one, T5, is 2. I'm told it's 2. This is 2, 4. This is 2, 3. So the formula for the harmonic mean, it says RH equal to the number of treatments T, which is what, guys? It's 5, right? Divide by, it says the summation of 1 over Ri, isn't it? Sometimes here, guys, it's the matter of if you know how to use a calculator. The reason why I'm emphasizing this, usually students, they lose marks when coming to finding the harmonic mean. You have to be careful on how to use your calculator, guys. It's possible if now we are going to get different answers because of what? Some of you are still having some problems when coming to BODMAS. BODMAS is killing you guys. So let's go. So it means this is equal to 5 over 1 over, what is the first replication? 2
over
plus
2. 1 over 6.
1 over 6.
1 over 4. 1 over 12. 1 over
12.
4.
1 over 4.
And 1 over 2.
What is the answer? Please write your answers from on the chat. You will see we're going to get different answers. Please write your answers on the chat. So, write it in full, my leadership. Homo, what is that? 10 over 3 is the same as what? 3.33. Let's see. It seems like you guys, you are ready to prove me wrong.
Sir.
Yes. Yes.
I think maybe since this one is not our last, the final answer, maybe we may stick with 10 over 3 since statistics.
But I'm getting 3 point. I'm getting 3.5 from what?
3.5.
You see, so that's how you find if the problem is not balanced, Christopher. If the problem is not balanced, the only difference is that you must first find what? You must first find the harmonic mean. After that, you have what? You have your standard error as what? The standard error of yi dot or y dot j is equal to the square root of MSE. Instead of dividing your we are what? You are MSE by a common error. Now you calculated what? You calculated your harmonic mean. You put what here? 10.10 over 3. That is the only difference. So what is the difference between Duncan multiple range balanced problem for balanced problem and for unbalanced problem is how you find the standard error. Any question?
So the difference between student Newman and Duncan is basically when it's time to use the tables.
Thank you. So the method that I use to find the standard error for Duncan multiple range when the problem is not balanced is the same as when you are using Newman curls. Even for the Newman curls, you will need what? You will need the harmonic mean. For a problem which is not balanced, you need the harmonic mean. The other steps remains the same. Any question, leaders? Dineo?
Say I wanted to ask, or like when we are constructing the ANOVA table, will
Yeah.
the formulas for SST and SST0 change since well they are not the same?
Yes, agree. Remember leadership. We agreed that when the problem unbalanced CRD, we agreed that the formula for SST is equal to summation of yi dot squared divided by Ri. You agreed that here to be Ri, my sister, isn't it? Minus y dot squared over n, isn't it, my sister? So in this case, assuming my sister were doing that problem that we just did now, it means for you to find the first part from this formula, you will say what? You will say y 1 dot. I'm just giving an example based on the one that we're doing now. Divide by what? We'll divide by 2, isn't it? Plus y, the sum of the second treatment squared, divide by what? What was it was 5, right? It was 5 or 6. The
6.
second treatment.
6.
Yes. Plus, you see how we do divide by 12, the third treatment, plus we're still dealing with what? We're still dealing with the first part because our replications are not the same. So each and every treatment you will divide by its replication, isn't it, my sister?
Yeah, I get it, sir.
Yeah. And then for the total, we agree that is SSTO equal to double summation of yij squared minus y dot squared. We divide by what, my sister? By n. That's all. And but don't be careful when coming to SSE. The degrees of freedom of SSE, we agree that now will be what? N minus t instead of t into r minus 1. The degrees of freedom of error is n minus t. Are you following, my sister?
Yeah, thank you, sir. I got it.
Okay. Another question?
Sir, was the SST without squared?
Sorry? Sorry?
The last time, sir. Can you hear me?
You are breaking, but try again.
Okay.
The guy is breaking, guys. Can someone help me? Yes. Let me get the question. Msa, you want to help the brother? I cannot hear what the guy is saying.
No, I want to ask a question.
Okay.
So can you please explain this part there, double summation, SSTO equals to double summation y of I and j squared, that example.
Which example?
Unbalanced example that we just did, yeah, the treatment J5.
You want to understand which part? This one of SSTO.
Yes, sir.
It's Yij, right? You square lose the given information, right? Minus y dot dot squared over n. So what is your question, my sister?
Oh,
Can I
I
get
was
your question,
saying
my
let's
sister?
do it
Before which part?
I was saying this part there, double summation y ij squared. Let's do it example yeah, unbalanced.
It's fine. Can I please do it at the balanced one? I want to check something, my sister. Suppose we have A, B, C. That one is too big, my sister. 9, 6, 2, 4, 3, 7, 2. My sister, are you there? My sister?
Yes, sir.
Can we please
Yes,
let's
I'm
find
still here.
yij squared. Double summation, right? Let's find this part. How do you find it? This is balanced.
We sum the square of
Can
the
someone help
base.
the leader here? No. Don't confuse that with this one. Don't confuse what I'm asking with. Don't confuse it with this one. My sister, when you sum all the values, you are getting y dot dot, isn't it? Y dot dot, my sister, y dot dot is the same as summation of y. Remember when we do summation of y? When you add,
Yes,
let's say when you add these values, what are we getting? Can someone add the values? Here I'm seeing 7. Let's add the values. 219. How possible is that, my sister? This can't be 219. If we have 2, we have 2, we have 3, 9, 4, 7, 6, 4, 2. How do we get 39, right?
It's for the y.
12. I'm saying let's do the one that is. Okay, sorry. No, I want to explain to my sister first. 947. This is what? 947. This is what? 9. This is 11. This is 20, right? So my sister, the one who asked the question, when you add this the sum of the treatments, you will get what? You will get summation y dot dot. When you square it, you get something. But this one of double summation of yij is 2 squared plus 2 squared plus, can you see it, my sister? 3 squared.
Yes, sir.
I'm not sure if my sister is still there. Plus 9 squared plus 4 squared. Yeah, it's fine. Here we're emphasizing, we're trying to explain how do we get to that 219. Do you understand, my sister?
Yes, sir.
Up to 2 squared, the last one, right? From the third treatment. Asking me if to say, you are saying, let's do it in a case where the problem is not balanced. That's what you said, my sister, isn't it?
Yes, sir.
So let me make this problem to be not balanced. Sorry, what am I doing now? Can you allow do you allow me to remove this?
Yes, sir.
Now the problem is not balanced, my sister. Okay. Allow me to remove this. That's squared, right? So that's how you find the double summation of Yij for the problem which is not balanced. Do you agree?
Yes, sir. Thank you.
It's not not difference. You add what is there. It's not going to affect the formula. But if the problem now is
Okay.
like this, if you are going to apply Newman-Keynes, you will need, and please guys, don't quote me wrong. The harmonic mean applies and Duncan only. Newman-Keynes and Duncan, that way you can calculate the harmonic mean. But if you are using LSD, you don't need the harmonic mean, please. Candy, you are saying something? What were you saying? I noticed that now your network is better. Candy?
Sir, can you repeat what you just said now?
Which one now? I said the Candy.
Oh, sir, I wanted to know the SST formula for unbalanced.
I'm here. I'm back. My sister, what were you saying? Can I continue, guys?
Yes, sir, you
No.
can continue.
Thank you very much. So please, when I say let's meet during the tutorials, try to do the questions before the tutorials, guys, because these things of when we get there, we have to solve the questions together. We are not learning by doing that. Solve the questions before. When you come to the tutorials, you are just there to confirm if what we have done is correct. It doesn't make sense for us to spend 1 hour 30 minutes during the tutorials as if we are doing something new there. So please, guys, help yourselves. When you get the tutorials, just come to do what? To confirm your solutions. You don't have to be attending the tutorials for 1 hour 30 minutes. Be strategic in this case. Come do the problem. When you come to the tutorials, you are just coming there to confirm your answers. Let's move, guys. Let's move. Rampedi, your mic is on.
Sir.
Remember, you want us.
Sir.
Yes. Rampedi, can you please mute your mic? Rampedi, Stanley? Stanley, before we remove you from the class, please mute your mic. Let me look for Stanley here. Sorry, guys, let me try to mute the mic. I got him. Yes, the only option that we have, Stanley, is to remove you from the session. Please, can someone call Stanley to mute this mic? The only option that I have here is to remove him. I don't want to remove him from my class.
Remove it.
Oh, here it is. It's fine.
I remove him.
Oh,
We will rejoin when he's serious.
I got the option now. Thank you very much for helping me not to remove Stanley. Candy, I seem like you wanted to say something. Candy, can I get your message first?
Oh, sir, Candy was asking what was the formula for SST for unbalanced.
I gave you, right? SS. I think I gave you, and it's also part of the what? Let me check from me. Leaders, if you check the notes, sorry, the study guide, the information that we're asking is there. But during break, I will project the study guide so that you see that the formula is there. I have only one timekeeper, which is Ramaila. If Ramaila is not here, we're not having a break. Remember, she's the only timekeeper that I recognize.
Lara said we didn't agree on that.
No, I'm the one who elected there, so my rules stand. So if Ramaila is not here, it means you are not going for break. So we're waiting for Ramaila. If she's not here, she has a right to open a mic and say something if it's time for the break. Now we move to. So please, guys, I'm giving you a task to go and apply the taking method. Now let's just stick on this 4. Go ahead and try to apply the taking method. If you don't understand it, you will discuss it. The Danet one, don't worry. Method number 5, don't worry about it. And now I want us to move to estimation of the model parameters. Ramaila is not here, right? The estimation
she's having network problems, sir.
She's here. Can she please raise up a hand or write something under the chat? I cannot go if the message is not from. We cannot go for a break if the message is not from Ramaila. Otherwise, she has to hand the powers to Mabunda. Blessing, you want to be a timekeeper if Mabunda is having problems, Ramaila is having problems. Blessing.
Yes, I can be one, sir. I can be one.
So please, from now on, you are working with Ramaila. If Ramaila is not in or she forgot about the break, you'll be the one to tell me if it's a break or not. So let's break for that 10 minutes. Let's break for 10 minutes. We will come back at let's come back at 1:55. 1:55, and we conclude the remaining section. The remaining section, 45 minutes, is more than enough to cover the remaining section. So for the quiz, you must know how to apply those. So far, you must know how to apply the first 4 methods for pairwise comparison, which is LSD, Duncan, Newman-Kells, and Turkey. After break, we'll do the confidence intervals and how to estimate the parameters. Thank you. Let's break. Please, I don't expect any question, guys, now. It's break time. Everyone should rest. So let's break. At 1:56, Mabunda, I want to hear your voice, or Ramaila, I want to hear your voice at 1:56. Thank you.
Sir. Sir.
I'm listening.
How are you? Yeah, we can
I'm enjoying.
continue.
Thank you. Thank you, Ramaila, for being a good timekeeper. It's good if you forget the break one, but for the one who coming back, it's very, very important for me. So we can find them. We can check which means are not the same. I think check the notes before you can ask the question. I think the formula there, there's a part where I said this for unbalanced, this for balanced. But I will check that. Now, please allow me to continue. We'll get back to check the method first, because tomorrow we're having a tutorial. I will make sure that from that tutorial you have to apply taking method so that you practice on how to use the taking method. So remember this model. Remember this model from the beginning of chapter 2. I explained how to write that model, and now suppose I ask you to estimate the overall mean. If I ask you to estimate the overall mean, I'm asking you to find what? Y bar dot dot, which is equivalent to, remember, mu. We agreed that mu is the population mean, isn't it? Mu is the population mean. That's how we agreed, and you also know this from first year. So if you want to estimate the population mean, you put a what? You put a head. A head, it means this what? This is the estimated population mean, isn't it? So it's equivalent to, by finding y bar dot dot. You know how to do this because it was part of the tutorials. So the reason why you have to understand this, because we have to move to the tutorials, to the confidence intervals. So looking at this formula, guys, we agree that errors are normally distributed around the mean of 0 and sigma squared. So it means now we can write our formula as follows. If you want to estimate the tau I want you to get to this one. I can go to the confidence interval. There's something that I want to bring in here. It is this part, guys. This part. Can you see this part? Tau I. So I have to explain this before I move to the confidence intervals. We said the tau I is equal to yi dot minus y bar dot dot. I want to go to the whiteboard first. I want to explain that. I explained that there are two ways of writing the what? The null hypothesis, with the assumption that the summation of tau i's is equal to 0. We agreed that there are two ways of writing the hypothesis when we are focusing on the fixed effect models. Yes, Manyama?
Sir.
Where tau I? Yes.
Sir.
Yes.
I have a question here. On the treatment
Yes.
of unbiased, when you were saying we were finding the sum of square of the treatments, I want to understand that formula where you said we must have those different. We have different sample size. When we find the SST, maybe try to elaborate. Maybe I did not hear you well, because now it's trying to confuse me in my brain.
Can someone help me? I'm not sure if I understand what Manyama is saying. Can someone explain what Manyama is asking?
Sir, I got it on the treatment SST. We have like R, which is different.
Yes.
I want to understand. It's confusing me like now.
What is confusing, Manyama?
Maybe let's try to find this SST for unbiased. Say.
Yes, here it is. Yes, the problem is unbalanced, right? This is 6. This is 21. This is 4, isn't it? Are you there, Manyam?
Yes.
Are you following?
I'm following.
These are the sums, right? This is the sum for the second treatment. This is the sum for the third treatment. So can someone give me the answer here? I assume there's someone who managed to hear what I was saying. Can someone give me the answer? How do I write the first part?
So you wanna say squared
Wait,
divided
guys. The leader is trying here. He said, I will say what? My sister, continue.
So first you're gonna take the 6 and then square it divided by 2, and then take 21, square it
Yes.
divided by 3, and then
Yes.
add 4 squared divided by 1.
That's 4 squared, right?
Then you're gonna minus
this is one thing, right?
that's 6 plus 27, 27 plus 31 squared.
Now it
Divide by what?
makes sense. It makes sense. It makes sense.
Divide by what, my sister?
N, which is 2466.
What is the question, Manyama?
I was saying now I understand what is happening. What is the notion saying? I was confused on the summation, but now it's making a lot of clearance.
Thank you. Thank you. So I was saying, as a boy, before Manyama can ask a question, I was saying, I will agree that there are two ways of writing what? Of writing the alternative hypothesis and the null hypothesis. I said you can use this method where you say that it's possible, an equivalent method where you can say A0 tau 1 is equal to tau 2 equal to, suppose we have only three treatments. We can say this is equivalent of saying mean 1 equal to mean 2 equal to mean 3. It's equivalent to that. But remember, the means, when we write the means, we cannot equate the means to 0 because we are not testing if the means are equal to 0. But with the tau i's, there is this condition that the summation of the tau i's is equal to 0. So the alternative hypothesis, it will say what? Not all tau i's is equal to 0, isn't it? Not all tau i's is equal to 0. So based on this other hypothesis, the tau r, if I ask you to estimate the tau i's, if I ask you to estimate the tau i's, the formula is given by what? Y I dot the mean for each treatment minus, oh sorry, here you have what? Y dot bar. You know these notations, guys. You know that this is what? This is the sum for is the mean for each treatment. This one is the what? Is the overall mean. If we are having 3 treatments, like it may be in our case here, we have tau 1, tau 2, tau 3. When you sum the answers for your tau, the tau i's, you must get what? You must get 0. So based on the example that we did, guys, Which one can we follow? We have an example that we have the means and all these things. The one that we used to do the pairwise comparison. How many treatments were we having there? 3 or 4? The one that we used to do the pairwise comparison.
3.
3.
So anyone who still remember the means for treatment 1? Can someone remind me about the means for the 3 treatments? Let's go, guys.
15.75.
15.75.
15.75. The second one?
14.625. 14.625.
14. Thank you. And the third one? Y bar 3.
17.625.
17.625. And the overall mean? Is that the overall mean? Y dot dot. 16. Thank you. Are we having same replications here? What were the are we having same replications? What is our replications? Can someone give me the replications? How many replications did we have from the problem? Thank you. R equal to 6. So now, can you please calculate the estimate the tau i's? Someone is saying 8, someone is saying 6. Which one is correct? R is 8.
7.
Thank you. Yes.
Yeah.
Someone just called my name and said, yeah. What is happening? Guys, someone just called my name and said, yeah. Or maybe I'm hearing things. Let's continue. And tau 3. I'm told that the first information here is I'm told this what is the value there? -39.
The value is negative 0.25. The first tower estimate.
Negative 0.25. The second one?
It's negative 1.375.
Negative 1.375.
And the third one, it's 1.625.
1.625. Let's check the condition. When you add the taus, what are you getting?
0, sir.
When you add the taus?
You get 0, sir.
So we get 0. So suppose we are writing a quiz or a test. I decide to give you tau 2 and tau 3. Let's say I decide to give you tau 2 and tau 3. Do we need tau 1?
Can calculate tau 1 using the condition of the summation of taus equal
Thank
to
you
0.
very much. You can use, I think I agree with Mr. Manyama. You can use, you must first check what is what is the sum of these two. Because at the end of this day, you must have what? You must have 0. So if tau 1 is not given there, it doesn't mean that tau 1 is equal to what? You cannot say tau 1 is equal to 0, right? You cannot say tau 1 equal to 0 unless if when you add these two, you are getting zeros, isn't it? If you add tau 2 and tau 3, you are getting 0. Then you can say tau 1 is equal to 0, isn't it? But here, because when you add these two, what are you getting? Negative 1.375 and 1.625. When you add these two, what are you getting? Tau 2 and tau 3.
0.25.
So it means for you to get a 0, it means this one is supposed to be what? Negative 0.25. So that when you add the 3, you will get what? You will get a 0. So now when you add the condition now is not violated. So we're happy. So the reason why I have to explain this is that now you can also write your SS treatment, right? You can also write SS treatment as summation of. Can you allow me to remove this part here, because you know it's 16. I need this space. You're allowed to write the formula for SST as Ri multiplied by tau I hat squared. So that is another formula that you can use, guys, to find the SST. Let's test it. Let's test it. Let's test this, guys. What did you get as your SST last time? What is your SST? SS treatment, guys. What did you get? I'm trying to trace the answer. SST, you got negative 36,75. Let's check it. Use this formula now.
No, it was 30.
Use this formula, guys, to check. What are you getting now if we use this formula?
Sir,
yes.
I can't see the formula proper. They're saying the formula there is summation tau.
There's
Or
Ri.
It's R.
Ri multiplied by tau I hat squared.
Thank you, sir.
Since it's fine. Since we have the values, I can erase here and write it nice. SST is given. This is another formula that we can use, guys. Ri, in case there's a possibility that you can have different replications, multiply by tau I hat squared. What are you getting, guys? You will say 8 multiply by negative 0.25 squared up to what? You write even the second one, and the last one is 8 multiplied by whatever there. Are you not getting the same answer, guys?
They are the same.
That is same. Why am I saying this, guys? Is because it's not always the case when you are writing an assessment will give you the data set. I can decide to give you the summary of the data set, and you must know which formula qualifies to be applied. So this formula again can be written as, from there we'll move to SSE. From there I'll move to SSE. Let me remove this. Sometimes the formula can be written as yes.
Sir, I want to understand. Yes. When we write a test, when we are busy writing our assessment, even us,
yes.
are we allowed to say if the data is large, but we use our calculator and I include only 2 data sets there and the last one and use that dot.
Yes, it's fine. There's no need for you to write to copy that information down. Even for, let's say, there's no need for you to show me how you find y dot dot. You just add the values. You show me that my y dot dot is this one. my double summation of what squared. This is the value. You don't have to show me the values how you got a double summation of yi squared. Just do it somewhere. What I want to say is where is double summation of yi squared? I don't want to see that you multiply saying 2 squared plus 3 squared plus 4 squared. I don't need those things. So this is the same as, so I want you to check it, guys. You have these things minus you can agree with me that is the same, isn't it? Because the part which is inside the brackets, the part that is inside the brackets is tau I, isn't it? Can you see it? Can you see it, guys? So you can also write the formula like that. So please don't memorize these things, guys. Moving to SSE. So this formula caters for balanced problem and unbalanced problem, because the R can change. The R can change here. So the formula qualifies for balanced and unbalanced problem when you are constructing what? An ANOVA table. So moving to SSE. Remember SSE from first semester, those who were with us in the first semester. SSE is given by double summation of EIJ squared, isn't it? Do you agree? Do you agree, guys?
Yes, sir.
So this can also be written in this format: Ri, which is the replication minus 1, multiplied by the sample variance of each treatment. Isn't it, guys? Here you can have, I'm not sure if I think I must have a summation here. Yes, you are right, Manga. I left the summation. Yes, who's talking? Christopher. Yes, Chris?
Oh, sir, I was saying, can you please use the black color more often?
Oh, okay. Thank you. Oh, the black one, not blue.
Yes, black, because these colors.
Thank you. Thank you very much. I will do so. But can you see what I wrote, or you want me to write these things again?
I can see they're just hitting our eyes.
Oh, sorry. Let me, I don't want the attendance to drop now because of the colors. Christopher, what about now?
Yeah, it's okay, sir.
So I said this can also be written as Ri, summation of Ri minus 1, standard error for each treatment, or the variance. If I put it like this is the variance, right? But sometimes I must use different colors, Christopher. I will avoid using red. Ne? This is the what? This is the sample variance. Sample variance. This one, go back to first year if you don't know how to find the sample variance and get the formula. Sample variance. If I remove the squared there, it will be the sample standard deviation. R is the number of replications. R replications. Any question? So for you, when you are practicing, guys, try to get used to these formulas. Use this one. Sometimes you use the other one. It caters for both. It caters for balanced and unbalanced, my brother Shokani. It caters for a balanced problem and an unbalanced problem. We're dealing with the CRD here. not another chapter. So these things, they apply for a balanced and unbalanced problem. So Ri, so it means if you are having 3 treatments, you must have what? The replication for that treatment and the standard error for that treatment. So if we're having 3 treatments, we'll have three variances, sample variance, and 3 replications. If the problem is balanced, we'll have we need only what? 1 replication, isn't it? We'll say R equal to 10. But if it's balanced, be careful when we're using the formula. So with that short note, allow me to go back to the confidence intervals now. From there, we're concluding this part. So the confidence interval, guys, please go and go through these notes now. Mabunda, are you saying something? Sorry, you wrote something there. I didn't see it. It's about what, Mr. Mabunda? My timekeeper? Oh, thank you very much, my brother. Let's work together, guys. We have to be free. You don't have to worry. If I call your name, it means you are the lucky one. You don't have to say Malek is calling me too much nowadays. You are the lucky one. You must smile. If I call your name, you must smile. So if you check here, I explained where you will use this formula, right? The tau I. I explained where you will use this formula. And then now we are moving to, and again, I can ask you to find the point estimates. The point estimates is given by this formula here. You are not seeing it for the first time. If I ask you to find the what? The point estimates, I'm simply saying, give me the values of what? Of the tau I. The point estimate for each treatment is, it will be what? You have to find the value, so estimate what? The treatment, the tau I's. So you use this formula here. So it's possible that I can ask you to use the confidence intervals to tell which means are different or which means are the same. So for the 4 methods that we discussed, for pairwise comparison, you must know their confidence intervals. So it's going to work like this, guys. Let's go back to the LSD. You will help me because you are the ones who are having the answers. I want us to, so it's possible that I can say find the confidence interval for treatment A. It means you will use this one. If I say find the confidence interval for a certain treatment, it means you use what? You use the first formula. You cannot conclude about the mean being significant or not using this one. You can only conclude if the means are different or not, or the same by comparing what? If you check the first part here, is what? You are having the difference between mean I and mean J. But the first one, you are just finding the confidence interval for a certain treatment. But the second one, you are finding the confidence interval for what? For the differences. So this is the confidence interval that can be used to check if the means are the same or the means are different. But the one that is indicated here is for the LSD. Confidence interval for LSD. So this one is the confidence interval for LSD when the problem is what? problem is balanced. So if the problem is balanced, you can use what? You can use this formula. I think there's a question. Yes, it's possible, Shogun. It's possible. But we'll cover it not now. It's possible, leadership, but not now. I'll show you. So I want us to go back to that class X, the one that we're just doing now. Please find the confidence interval for using the LSD method. Find the confidence interval, use this formula, and check which treatment means differ. If the confidence interval includes 0, it means there is no difference between those two means. If the confidence interval does not include 0, it means the two means are not the same. So now I want us to go back to that class example. We use this formula. From there, we'll move to Newman-Keynes. Let's go, guys, or Duncan. Problem is balanced, use this formula. Can I go to the whiteboard? I can write the formula, that side is fine. Time is no longer on our side and we're supposed to conclude, sorry. Cancel, I don't need this. So remind me about those means.
Sir,
yes.
The confident interval of the treatment of the example of 3 programs. Do you want the final answer or those means first?
No, let's write so that if those who didn't do the question can understand what is happening. T-tab. Let's get everything. The difference between min 1 and min 2 is what? Min 1 minus min 2. If we can give an example of 1, it's 9/8. 9/8 plus or minus t tabulated is what? Sorry, Christopher. This thing by default, the color that is using is blue. Ne? Sorry for that, Christopher. 2.080. Can I write the formula using that blue again? Multiplied by the square root of 2m. Is the problem balanced? So, sorry for that, Christopher. This thing, let's go. Square root of 2. So we don't have to waste time here. 2. MSE was what?
$10.726.
10.726. So you have these guys, plus or minus this part here. So what is the final answer? Manyama, it seems like you're having the final answer. Manyama, can I get the final answer?
Sir, I don't have the final answer. I just did the example for the treatment only. Then I went to.
Yeah, someone is having the answer. Negative
281.
Okay, the upper part.
Then it's 4.5.
4.531. Thank you. So what are you saying about the difference? Is there any difference between min 1 and min 2? Is there any difference between min 1 and min 2? We're comparing these two now. Is there any difference? If the confidence interval includes 0, if the confidence interval includes 0, it means there is no difference between those means. If the confidence interval does not include 0, there is a difference between those two treatment means. Christopher? So no difference.
So can you repeat that?
If the confidence interval includes 0, it means there is no difference between the treatment means. If the confidence interval includes 0, it means there is. If the confidence interval does not include 0, it means the two means are not the same. If the confidence interval includes 0, like ours here, it means the two means are not. The two means are the same. So we can simply say what? Insignificant. Insignificant meaning, what do you mean by this? Mean 1
So you
is the
lost me
same as
again. So you lost me. You lost me. Can you repeat what you just said?
if mean 1, if your confidence interval includes 0, if your confidence interval includes 0, it means the two means are the same. You are still lost.
I'm with you now.
If the confidence interval includes 0, it means the two means are the same. If the confidence interval does not include 0, it means the two means are not the same, isn't it?
Sir,
Yes.
do you mean 0 from the number line or Jan? I'm confused.
Zero from the number line. Thank you very much. I was
Okay.
coming to that one. Christopher?
Say, what if I said mean 2 minus mean 1?
Mean 2 minus mean 1. You'll be guided by my question. If I ask you to find the difference between mean 2 and mean 1, it means when you write, you write y2 dot minus y1 dot. You cannot do this if I didn't tell you to do this. Because the correct method of comparing is what? Is y1 dot minus. If you're finding the difference, you follow the order of the means. Yes, Manyama?
Myself, I'm interested when it comes to the interpretations of our final answers.
Of what?
The same example we are doing.
I'm lost now. Which final? Now I'm saying the question will be saying, use the confidence interval procedure to check which means are not the same or which means differ. That is the question, Mr. Manyama. Use the confidence interval procedure. Yes.
If that's the question now, it means the interpretation will be clear. I was assuming if you were saying
no,
you don't have to find the confidence.
No, usually I will ask you to find the confidence interval for the sake of checking. Instead of you are replacing the pairwise comparison by the confidence interval. You get it? I would say instead of using the pairwise comparison, use the confidence interval method to check which means are what, which means are different. So now, with the remaining 4 minutes, allow me to go to Duncan. So you can do all the comparison for those three means. So far we got between y1 and y2, mean 1 and mean 2. You said it's insignificant, isn't it? Insignificant. That is the confidence interval. What about between mean 1 and mean 3? What is happening between mean 1 and mean 3? What are the values? What are the values? The same values. 15/8 and what? It can't be the same. If you're having 15/8 already, what is the upper limit? What is the confidence interval between mean 1 and mean 3?
The
and
lower
mean 2 and mean 3?
1.53.
Sorry?
The lower is negative 1.53.
Negative 1.53, and the upper limit is the one that Omu gave me, 15.8 or 5.28.
It's 5.28.
Still the same. Looking at the two values, it means that again min 1 and min 3 are the same, right? Let's go to the last one, min 2 and min 3. What was our conclusion, guys, based on this example? Our conclusion was there is no difference between treatment means. We failed to reject the null hypothesis for this question. Oh, thank you. Thank you very much. I'm surprised now, because if all of them now, they're giving us this. So even the other one is having a negative and a positive. So if you can check, even the confidence interval, they are suggesting the same thing that was suggested by what? By the pairwise comparison. All of them, they include 0, which means the three means are what? Are the same. So when moving to Duncan, guys, when moving to Duncan, you move to the last step. What is important is the last step. You compare. Let me remove this. I noticed that time is no longer on my side. I know Mabunda and Ramaila, they are busy exercising to say it's time up. So when we're talking about Duncan
You can
multiple,
continue. You can continue.
thank you very much. I love my timekeepers. When coming to Duncan, multiple range test, confidence intervals now. Again, for Duncan or student Newman-Kells method, how do you find the confidence intervals? Confidence intervals when using Duncan multiple range test or student Newman-Kells range. Remember step 5? What do we do with step 5? We say largest, right? When we're doing minus smallest. Remember we do something like this, and we compare it with what? We compare it with the significant range, isn't it? This is what we do, isn't it? We used to put what? We compare this with a significant range. So now the only difference is what? Do you get it, guys? Largest minus second smallest. Now, instead of putting a greater than sign there, instead of putting the greater than sign, you put T plus or minus RT minus 1, isn't it? You get the logic, guys?
Yes, sir.
So for tomorrow's tutorial, please, we have to use the confidence interval procedure to check which means are the same or which means differ. And by doing so, we'll be concluding our chapter 2, part 1. So that's what we're supposed to cover for chapter 2, part 1. So let's recap here. You must know how to apply Newman-Kells, LSD, Duncan, and Takey, and also know how to find what their confidence intervals. So in a test or a quiz, I can specify which method I want you to use. I can say use the confidence interval method, or I can say use the pairwise comparison method. So if I say use the pairwise comparison, you know the steps. If I say use the confidence interval method, here are the steps. So please, guys, now tomorrow we'll be going to another section. So make sure that you understand this section before we move to the next section. Ramaila, feel free to tell me the good news.
Sir,
Yes,
yeah, time is up.
thank you. Those who want to remain with me, they can remain. Those who want to go, they can go. Yes? Can you allow me to stop the recording? Because now it's consultation time. Should I stop the recording? Thank you.